Greetings, everyone, and welcome to the virtual Small Cell World Summit 2022 for the US regions. I'm Prabhakar Chitrapu, Chairman of the Small Cell Forum, and I'm honored to invite you all to take part in this summit. As you know, we had an in-person Small Cell World Summit in London 2 weeks back, which was a resounding success. And this event is a follow-on, which is virtual, of course, and is targeted for the US regions. Most of the content is new and is, as I mentioned, targeted towards the US audience and US markets. But we do have some common content that is also reproduced here from the London event. The agenda is packed with very interesting and stimulating and business relevant and timely presentations and panel discussions. I'll briefly go over the agenda and what you can expect. We start off the event with a set of keynote speeches from Qualcomm and Rethink Technology Research. And that is followed by 3 technical plus business plus regulatory sessions focused on, first, emerging technologies and 6G. The second is navigating the deployment of private networks with CBRS. And the third is Open RAN and neutral hosts for accelerating 5G small cell deployments. We have presentations for the emerging technology from Nokia Bell Labs, Reliance Jio, Google, Lockheed Martin, and InterDigital. The private network session has presentations from Qualcomm, CommScope, HQ, and Reliance Jio. And the Open RAN and neutral host session has presentations from Picocom, Ericsson, Crown Castle, Parallel Wireless, and Meta. Each of these sessions is a combination of presentations and panel discussions. So I hope you will agree that it's a very packed, interesting agenda. And I invite you once again to sit back wherever you are, at home or in your workplace or in some public location, and enjoy listening to the presentations and panel discussions. I hope you will learn and benefit from these as much as we did during the preparation of it. Thank you very much.
Hello and welcome, everybody. I will talk today about the digital transformation of industries, and in particular, the role of radio access network architecture that has to do with the digital transformation. If we look at digital transformation right now, we see 4 different trends that are driving from a radio access network perspective this transformation. One is densification with small cell. The more industry are digitally transforming, the more we need dense network to provide the connectivity and optimal connectivity to these industries. The second is millimeter wave as a huge opportunity for this small cell densification. The third is about private networks. Of course, when we talk about digital transformation, this transformation can be enabled either by a traditional mobile network operator or by the industries identifying opportunities for deploying their own private networks. And so that's a key component. And the last one is open and virtualized RAN as a way to disaggregate the RAN, reduce the cost of the deployment, and also enabling these private networks. So if we focus a little bit on the 5G small cell, densification is a key way to solve the challenges of the network right now. And this is not only related to the industries that I talk about it later, like enterprises, but it's also for residentials, smart cities, and stadiums. So what are the key aspects that small cells helps enable? First is scalability. We have seen many customers who look at an initial deployment, which is very limited, of one part of the factory or one factory, and then it expands the more we go, the more the business makes sense for them, right? So it is scalable when it grows whenever it needs. Second, of course, is coverage. Small cell is a key technology to enable indoor optimized coverage or to enable additional capacity, and that's one additional key aspect, when is needed. So the stadium is a key example, right? Big events requires, have a lot of people going into these events, so requires additional capacity, uplink capacity, downlink capacity. Small cells can provide that. And all of that, it can provide it with quality of communication, with quality of performance, because it's the small cell, the more you identify the network as a dense network, the more they can provide quality to the end customers. So if we focus for a second on indoor, there are different drivers that we've seen the last few years that has increased the role of indoor and indoor 5G in particular. Of course, small cell have been around since the 3G days, and we had deployment with 3Gs, with 4Gs, but there is definitely an increased interest with 5G of indoor deployment, and there are different trends that drives towards that. One aspect is what happened the last 2 years ago, with everybody went home and work from home, but that drove even more than working from home now. It is not only work from home, but it's work from everywhere, right? And so that's the key aspect of wherever you are, at the mall, in an airport, in an office, at home, in a coffee shops, you need to provide optimal connectivity for the user to be able to do video calls and so forth, right? So that's a key new driver that has always been there, but I think we have seen the last 2 years definitely exponential increase of the importance of that. The second aspect is what is happening at the application layer, right? Applications are moving to the clouds. More and more application, even basic things like file management, right? Everybody, I think all of us are using some sort of cloud management tool for file management. So everything resides in the cloud. Some or a lot of applications have processing done in the cloud. And so the connectivity between the device and the cloud becomes extremely important. It is basically impossible now to be productive without a connectivity to the cloud. And that is why it is extremely important to have a very good connectivity, and in particular an indoor connectivity whenever it is needed. So one key aspect of small cell and indoor small cell in particular is millimeter wave. So we believe that millimeter wave is a very cost-effective way to deploy indoor 5G. It is a way that it can enable better performance and better user experience. We have worked with Bell Labs. We have provided a study with Bell Labs where we have seen that it makes also a lot of business sense for operators and overall venue owners to deploy millimeter wave, where we have an significant increase on millimeter wave. And again, millimeter wave, we don't see that as a replacement of sub-6, is actually a complement of sub-6, where we have more coverage layers and some level of capacity layers with sub-6, and an increase of capacity in millimeter wave whenever it is needed. But millimeter wave indoor and giving indoor access for millimeter wave is only one of the use cases for which millimeter wave is used. We have many other examples. So one key example is what we call fixed wireless access, also known as wireless fiber, which is a way to provide connectivity in rural areas or underserved market, right? So it's really a way to bridge the digital divide. We have seen that really a strong momentum with, for example, US Cellular that has commercially launched 5G millimeter wave FWA in 10 cities in the United States. And Fastweb has done a similar service in Italy as well. But there are also other applications related to enterprise application. A lot of them have to do with either heavy downlink or heavy uplink. So a lot of them have to do with additional capacities, right? A couple of them are interesting. One is precision agriculture in UK, where there was a lot of sensors data that could be aggregated by gateways and provided back to the cloud. And the other was high definition professional video footage at the Carnival in Sao Paulo, where mobile operator Claro offered TV broadcaster Globo to follow the samba bands along the street, uploading the live content to TV viewers, so requiring a lot of uplink and traffic, right? So these are just some of the 5G millimeter wave applications in different countries, and we're seeing more and more to come. Now, specifically in North America, also, I think from a Qualcomm perspective, we have launched with our Qualcomm 5G RAN platform for small cell in collaboration with Samsung, the Samsung Link Cell, which has been deployed by Verizon indoor. A similar product has been deployed by Corning, also indoor for Verizon. And this allows for integrated, basically, a millimeter wave and very good offering for indoor provided by Verizon in non-standalone mode right now, right? Where we have high throughput and low latency for venues and businesses. That has been really a success story for us. So going back to the trends that we have seen earlier and the importance of small cell, the other key aspect that I mentioned is 5G private network. So 5G private network is definitely a key technology and opportunity that we are seeing right now. And the reason why it's a key one is, first of all, see there, $3.5 billion global private LTE and 5G market size by 2026. That's what Mobile Expert is predicting. But the aspect that is really interesting about private network is the diversity of the use cases. These slides show some of them that we have discussed with some of our customers, from mines to manufacturing to warehouse, airports, and hospital. And all of these private networks are different by nature, with different requirements and different way of being deployed. And that's where the challenges come from an end customer perspective, but also as a technology provider like Qualcomm, right? So how do you really deploy private network in a scalable manner? How do you extract full potential for 5G? Low latency when low latency is needed, high capacity when high capacity is needed, or ultra high reliability and low latency. So it is very important to define a framework that allows to deploy these networks. The additional point and additional challenge is that a lot of these end customers are not wireless experts, right? It's not like deploying like a Verizon or AT&T who deploys a mobile network, nationwide mobile network, or even a network that is in a stadium. This is about an industry that is going through a digital transformation and therefore has to deploy a private network. Thank you. There are no wireless experts in that industry. So how do you have a one-stop shop solution that allows to be really simple in the deployment, planning, and management of these private networks? So from a Qualcomm perspective, we have defined a comprehensive approach to 5G private network. We have announced that at Mobile World Congress in Barcelona, and it's really a partnership and ecosystem play. So first of all, we have defined a 5G private network partner ecosystem program where we work with multiple vendors in order to test and pre-validate end-to-end solution, private network end-to-end solution. And these end-to-end solutions are specific to certain verticals and certain applications and use cases. And we are testing a lot of the solutions, just not from a functional perspective, but really from a performance perspective, so that when the solution needs to be deployed by the customer, has really been pre-validated and pre-tested. This, of course, is enabled by our 5G RAN platform for small cells, which is enterprise grade and has a lot of vendors ecosystem. So we can have the end customer has multiple choices from Qualcomm partners and customers that we can use different small cells depending on the form factor and the particular requirement. The additional aspect is to enable, again, multi-vendor through a Qualcomm private network RAN automation solution. This RAN automation solution allows for easy deployment and management of the private network, so that the combination of the partner program and the RAN automation solution allows really for a multi-vendor deployment, which is easy to deploy and to manage. Because it's important to have a multi-vendor ecosystem, because as I said earlier, private networks are diverse by nature. And so it is impossible that the same exact solution could work for an airport and a mine. So you need a multi-vendor solution, but at the same time, you need a common way to manage the different network or a common way to validate the network. And that's where our approach steps in with the partner program and the RAN automation program. The other key aspect of private network is the importance of ORAN and vRAN as virtualized RAN and open RAN. The private networks are ways to deploy networks that are not traditional. So again, there is not a one-size-fits-all solution. There is not a solution where you use the big macro massive MIMO radio unit out there, or you use the very high capacity distributor unit. You need really to put the resources when they're needed and to disaggregate the network in order for the network to be more flexible for the different private network opportunities. And that's why virtualized network and open RAN networks are important. And from a Qualcomm perspective, we have a portfolio of solutions that can support this deployment. I've already talked about the Qualcomm 5G RAN platform for small cell. We have, of course, our first generation 5G solution, millimeter wave and sub-6 with FSM 100. And we have our second generation 5G RAN platform with FSM 200, which supports, again, both millimeter wave and sub-6, with up to 200 megahertz of sub-6 spectrum across FDD and TDD, up to 1 gigahertz of bandwidth for millimeter wave. Right? It is an ORAN compliant solution. It supports all the functional split and can be used for the different deployments of private network and public network, of course. But then we have also non-small cell part of the portfolio with our QRU, Qualcomm Radio Unit Platform, which enables, again, macro level deployments for sub-6 with massive MIMO and no massive MIMO, TDD and FDD solution, and millimeter wave. And our Qualcomm distributor unit platform also enable through inline accelerator card like the X100 accelerator card. And all of this completes a portfolio that is very flexible in the way we are enabling the deployment of the different networks. So we have really talked today about the digital transformation, the importance of technology like small cell and millimeter wave within that digital transformation. We talk about the new requirements and challenges that private networks provides with the importance of multi-vendor, our partner program that we're doing for private network, and the new Qualcomm solution for RAN automation, and the importance of open RAN and virtualized RAN to deploy in these networks. So it's really a new wave of technology that we have to support all together. We refer to this as the modern network, and it's really, really exciting to work in this area. So thanks a lot, and to the next time.
For those who don't know me, I'm Caroline Gabriel. I'm the content director for Small Cell Forum, among various hats that I have. I'm also the co-founder of Rethink Technology Research, and I'm a research director at Analysis Mason. And each year, we put together the market status and forecast for the forum, which I know is always a sort of hotly awaited report. The key input to this is a survey that we do of operators and small cell deployers. And this year we had response from 76 mobile operators and 42 other deployers of small cells. So that includes private network operators, neutral hosts, and so on. And obviously those sort of alternative deployers are very central to the forum's work now. And though the responses to the survey, they tell us about their deployment plans, their business models, and so on, and that feeds into the forecast, which will be published in its entirety next month. So you'll see the full report. Today, I'm just going to share a few highlights as a taster of that report and hope that they will stimulate your interest, and I think they will set the scene for a lot of the themes of the next 2 days. The forum itself is very much guided by operators and deployers, so it's no coincidence that the shaping of the forum's programme, which is reflected in the themes of this summit, very much align with what we're hearing from the respondents to the forecast. So when we look at the role of small cells, we've identified this year 5 key areas that we think are essential to the next phase of 5G, to really starting to fulfill the promise of 5G, which to date has largely been focused, as we know, on what we call 4G plus business models centred on mobile broadband. So there are 5 areas, and they're highlighted also in the brochure, the conference brochure content that you'll see, that we think are important, and where small cells are playing a central role, sometimes a leading role even ahead of macro network deployments. So a diversity of use cases, particularly as 5G standalone starts to be deployed. A diversity of operating models to support these different use cases, including private networks, neutral hosts, shared networks, and so on. Evolution of the architecture to support a much wider variety of use cases and services. A lot of that architecture evolving on the basis of open standards, such as small cell Open RAN, and a greater diversity in spectrum and regulation, which is critical to enabling some of these new deployers. And all these trends will help to drive the growth in deployment of small cells, which you can see just the very top level result of the forecast. Here split by region, this is all kinds of small cells, public, private. As I say, when the full report is published, you'll see lots of breakdowns by different types of small cell, different business models. But just to give the top line, you can see it's not a straight curve. There's a CAGR of about 19% between now and 2026. You can see quite a sharp uptick from between 2021 to 2023. A lot of that's driven by enterprise and the start of 5G in private networks. Then it eases off a little bit and we get another big leap towards 2026. That's partly driven by some emerging economies starting to densify, also by the next phase of 5G rollouts. As I say, the overall big driver is that 5G is becoming real, emerging for its 4G plus phase and starting to drive real change in what industries, mobile operators and all kinds of enterprises will actually do with wireless connectivity, And that in turn is changing the structure of the industry that supports those networks. So you can see in this graph, this is showing the increase in 5G as part of that installed base that we just saw on the first slide. So getting up to about 11 million cells in total, but by 2026, about 90% will have some 5G in. Many of these will be multi-network. But the importance of this is not just that 5G is part of emerging networks, it's hardly a big surprise, but that it is driving this diversity of use cases, which in turn require a very wide range of capabilities from the network. So, to be honest, if we stick with 4G+, most small cells could stay 4G for years to come, and the installed base is very 4G centric. We see that particularly in private networks. There has to be a reason to upgrade and expand these networks with 5G. And there's quite a lot of trends and patterns that we see causing this. Some of it is the migration to 5G standalone, also to using wireless connectivity for mission critical applications, moving way beyond coverage and capacity, which were the traditional use cases for small cells. And some of that's relating to deployment in industries that do have critical comms requirements, such as transport, manufacturing, and so on. To support this diversity of applications, architectural change is important, but it's not sufficient on its own. The new flexible architectures that we'll see discussed during the summit are extremely important to be able to support different network behaviors cost effectively, but there has to be an expansion of the deployment models and the ways to monetize these networks once they're in place. So the classic MNO public network model will remain important, but it's not the only game in town at all. And this sort of diversity is enabled by progressive policies in spectrum, in siting, particularly outdoors, in sharing of the networks, and in introducing open platforms at every layer. This isn't just about RAN interfaces, it's about every layer of the network. And all that put together allows the wireless network to deliver a great deal more than mobile broadband. And on in the pie chart, you can see a result from those 46 enterprise and alternative deployers that I mentioned who responded to the survey, in terms of what they are seeing as the leading connectivity requirement that will drive their business model and their deployment. Because most of these alternative deployers have to justify their business model by going beyond coverage and capacity, by doing something that is not currently delivered by present networks. And you can see that truly ubiquitous coverage tops the list here. We've never achieved that with cellular networks, but a lot of industrial and IoT applications absolutely require it. Then low latency, integration of edge computing, extreme density, quality of experience in building, and the integration of AI analytics, particularly for sensor-based applications. So as I say, to support all these different use cases and all these different enterprise sectors which have different specific requirements of their own, one set of operators and service providers cannot possibly address that whole market. And so much of the Small Cell Forum's work in the last 2 or 3 years has centred on encouraging and supporting alternative models such as neutral host. And you can see the result of that. So this is the forecast broken down by the percentage of cells deployed up to 2026. And you can see that although, of course, MNOs remain an extremely big part of this picture, we estimate that they will, although they deployed over 40% of cells in 2019, by 2026 that will be just over 20%. And the big growth is in the neutral host platforms, going from 6% to 30%. I mentioned 5G standalone at the beginning. It's just sort of starting to become real this year. The big headlines are on the big public networks, of course, and we're seeing operators in the United States, China, Japan, and so on, starting to deploy the 5G core and 5G networks that really can enable these very different capabilities. But in fact, a lot of the drive behind early standalone is actually coming from enterprise and private networks. It's always easier to deploy a new generation of technology in a greenfield situation, and many enterprise and industrial networks are largely greenfield or just have Wi-Fi in place. And there are lots of offerings coming to market that combine small cells, sometimes a network in a box, sometimes a cloud-based small cell network, with a cut-down enterprise core that can even be deployed on-premise. So we're seeing a lot of the sort of innovation in what you can do with standalone coming from enterprise and therefore coming from small cells, whereas in the macro network, everything's a little more slow and conventional. So you can see here, as of the end of the first quarter, we tracked the number of standalone networks that were being deployed at a reasonable amount of scale. And you can see that there were 74 small cell examples compared to about 20 macro. That's not surprising. I mean, there should be larger numbers of small cell networks. There are more of them. But more interestingly, it's the innovation in how they're being deployed that caught our eye. So 24% of them in the small cell world are being delivered by new vendors to the market or by multiple vendors as people move to cloud-based core. And the numbers that are being deployed by private or neutral host alternative deployers, 47% of these small cell networks in standalone environment. So above the curve for small cell enterprise networks as a whole, as compared to just one down in the macro network. The core is, and the standalone network is fundamental to enabling all the use cases that we've been talking about. But architectural change in general is also important, partly to open up the ecosystem, but also to improve the agility of the network, the scalability of the network. So here's our forecast looking at enterprise and industrial small cells by their architecture. These are subsets, by the way, of each other. So the yellow is the total. The blue is any kind of virtualized RAN, and the orange is something with open RAN interfaces, such as the split 6 that Small Cell Forum works around, or the O-RAN split. And by 2026, we expect that about 70% of enterprise small cells will be adopting a virtualized architecture, and the big majority of those will support some flavor of Open RAN, at least as a minimum of the interfaces between the radio unit and the baseband unit. But some, of course, will also be deploying more extensive new platforms, such as the RAN intelligent controller. All of this helps to support the diversity of deployment and use cases. It helps new vendors to innovate, and it helps operators and enterprises to have access to those innovations. The risk of any sort of open network movement, and we've seen this many times through the history of this industry, is that it can be so open that it becomes very fragmented. So many vendors, many architectures and so on, it can risk leading to a lack of scale for anybody, which in turn usually then triggers a consolidation and a bit of a reverting to the original situation. The way to avoid this, of course, is to have open foundations on which everybody can innovate equally. This is hard to achieve, and I would say it's probably, once you move above the radio standard set by 3GPP, it probably has never really succeeded in the mobile industry yet. But we can look at the data center industry and the IT world and see many examples of the success of open foundations driving diversity and creativity. And we believe that the sort of use cases that 5G is now driving will be the trigger for a very new approach to open standards within the mobile industry. The core radio standards, of course, remain critical, but they are not enough on their own to support the diversity of what people and companies want to do with mobile networks. And this is where forums and alliances become very critical at distilling the requirements that the various stakeholders have and translating those into specifications that are deployable and that are actually useful to deliver what's needed. Theoretical specifications may be architecturally interesting, but they will rarely succeed in the real world. So a lot of focus, and you'll hear a lot about it in this conference, from the forum and from other stakeholders in the small cell industry, on setting open specifications, blueprints, reference designs, but ones that are really tightly aligned to the requirements of the sort of industries that are leading demand for dense 5G networks, such as manufacturing, transportation, entertainment, and so on. There are obviously various open architectures. There's a lot of work by different alliances to try to align with one another. The Small Cell Forum itself, as you know, bases its work on the with its NFAPI and Split 6 work on the 3GPP's Split 6 between the radio unit and the baseband. And you can see the growth in the percentage of operators that expect to deploy that by 2026. So almost half of small cell deployers or would-be deployers expect to deploy Split 6 in some scenarios by 2026. They may also deploy other splits as well, and there's a session tomorrow on Open RAN where we'll share a lot more detail actually about what came out of this survey about the often very complicated approach to open architectures. But what's really important, as I say, that there should be plenty of choices and plenty of flexibility for deployers, but for vendors underneath all this, there needs to be a common foundation to drive scale and cost effectiveness. And here I think work that the forum has been doing is important, not just on specs, but turning those into reference designs, which in turn can support blueprints for deployment in specific industries. This helps to make the diversity of business models more achievable and more cost-effective. And as those deployments take place, that real-world experience can be fed back into the next generation of specs and reference designs. And I think if you have to pick one critical role of an industry alliance such as Small Cell Forum, that is probably it. It's continual cycle of taking requirements from the industry, understanding them, turning them into foundations, and then refining them as the real-world situations become clear. So just one other aspect of this diversification of the platform, and that's spectrum. The spectrum that's available and how it's licensed and regulated. For new deployers to be able to address the needs of industries where perhaps the MNO model is not appropriate, they will obviously need access to spectrum, and they will need it cost effectively and in the right places and the right capacity. The amount of spectrum and the way it's regulated, of course, is always defines the networks that can be deployed, macro or small cell. But we are starting to see innovation in spectrum licensing, and again, we'll hear a lot about it in the conference. We all know about the innovations that are going on around the CBRS spectrum in the United States, which is setting some really important precedents for other regulators elsewhere. But we're also seeing shared access, lightly licensed, local license schemes here in the UK, in the Netherlands, in Japan, in many parts of the world where enterprise and industrial 5G is seen as being part of the national industrial agenda. So it's not just part of a telecom industry model anymore. And the graph here shows the deployment of small cell radios by the type of spectrum, so by licensed and by the various shared or local or light licensing schemes that are available around the world. And of course, there's more breakdown of this in the report. But by the time we get to 2026, you can see that about 60% of small cells are being deployed in non-licensed spectrum, which equates quite heavily to the presence of the alternative deployers in the market. So just a final remark to show the sort of impact of these trends and of the industry coming together to address them. It's still the very early stages of the 5G small cell networks in the enterprise market. So there is considerable upside and downside depending how all these factors play out and how the industry responds. So in our forecast, we obviously have best and worst cases. You can see by the percentages just how much there is to play for here. And we believe the real decider of pushing the industry more towards the upside model, which is 45% more in terms of units than our base case. We think that the key element of that will be cooperation across the industry and between all stakeholders, not just the telecoms industry, but the other industries that want to use wireless networks. And we think all the things we've talked about in these 20 minutes are important to pushing us towards the best case rather than down. There's a risk case of about minus 27%. If there isn't unity on architectures and if there isn't a clear response to the demands of enterprise. And on the right is just the same exercise done specifically for the neutral host deployments, which we think can play a very interesting role in driving more numbers into small cell networks by deploying networks that otherwise wouldn't exist, no one would find a business case for them. So a similar sort of upside and downside model you can see, also quite dramatic in the neutral host small cells. Thank you for listening. Do catch me, I'm around for the whole conference, so if you want to discuss any of this, and do look out for the full report, which will be published next month, and look forward to the conference. I know it's going to be a really great event.